Welcome to today's lesson on Surds 1. This will be a three-part series of Surds. We're going to start today with the basics of Surds. This lesson will be appropriate for you if you are in Year 10 doing GCSE Higher, or also Year 9 or Year 8 in top set. Hopefully you managed to download the worksheets and have a go at these questions to start. I'll start by just going through the answers to these. Don't worry if you struggled on some of them, because I'm about to explain them now. So this first one, expand and simplify. To expand and simplify, there's two methods. You can either do the FOIL method, which is the quickest and easiest way, or you can do the grid method. I'm just going to do the FOIL method here. Here we need to do r times r, gives me r squared. Then I need to do r times -8. The biggest misconception students make here is they think that this negative is floating in between r and 8. It is not floating, it is attached to the 8. Okay, so that is not just 8, it's -8. So we're going to do r times by -8, which will give me -8r. Then we're going to follow my lines here. We're going to do again, same conception applies here. That is -4, not 4. So I'm going to do -4 times r, which is -4r. Then I'm going to do -4 multiplied by -8. Now 4 times 8 is 32, and a negative times by a negative, we must remember, is a positive. So that will be positive 32. Looking at this, we can now tidy it up. You should be able to spot that these r's are like terms and can be simplified together. Now, this r squared is not the same as those two r's there. They are different, but we can definitely put the r's together. So that will give us r squared minus 12r plus 32. Okay, so misconception students make here. You're starting off at -8 and you're taking away 4 more. If you think about a number line, if you're at -8, you take away 4, it's going to get you down to -12. So that will be your final answer for that question. Moving on to the one on the right. This is an indice laws question. You need to remember that when you have the same base, which is 4, times together, the rule tells us that we have to add these powers together. So if I do -1 plus 2, we're going to get 1. So the answer to this will just be 4, because 4 to the power 1 is simply 4. Moving on to the bottom left. It says, Anna, Sky and Natalia shared some money in the ratio 9 to 5 to 3. The first thing you should always do with ratio questions, and if you're unsure about ratio or you struggled with this question, I've just done a ratio lesson this morning, which will be on the YouTube channel, which you can go and watch, which covers an example exactly like this and goes in depth about it. So the first thing you want to do is write A to S to N with a total. They share it in the ratio of 9 to 5 to 3. So that is going to be 9 to 5 to 3 with a total of, what's the total there? 9 is 14, 17. This is the bit that usually catches students out. Anna gets £28 more than Sky. So we need to focus on Anna and Sky. As you can see here, the difference in parts is going to be 4. So that is 4 parts equals the £28 more. So 4 parts, 4 extra parts is worth £28. This tells me now that 1 part must be equal to £7 by dividing both sides by 4. This is now easy. Once you know the value of 1 part, we can find the value of any part. 9 parts would be 9 times 7. 5 parts would be 5 times 7, and 3 parts would be 3 times 7. So what we're going to have here is They only care about Natalia. So Natalia is going to be 7 times 3, which is £21. So you don't really need to fill those in. You can if you want to, but we only care about Natalia in the question. Moving on to the final question in the starter. Increase 26 by 5%. There's 2 ways you can do this. The best way really is to just stick with one method that you would use with a calculator. And increase, if I'm increasing, I'm going to do 1.05, because an increase of 5% is 100% plus 5%, which is 105%. Okay? So 105% is 1.5 as a multiplier. So that is 26 times by, because I'm increasing 26 by a multiplier of 1.05, which is going to give us, so that's going to be 22.6, so it's going to be 1.3. So it will be 27.3. Okay. So this method is really handy. You can do a column to work that out yourself, or you can just whack it in your calculator to get the answer. So, moving into surds. Surds is quite a scary looking topic, but once you get the foundations sorted and you understand where it all comes from and how it works and the laws, they're quite simple. It looks really hard. Some of them do get quite tricky, but as long as you stick to the basic rules, you should be okay. We'll start by just looking at what a surd is. A surd is a square root of a positive integer, which is a fancy way to say a whole number. So you could add a note here that just says positive integer is going to be any number greater than 0. So for an example, they look like this. You've got root 18, 2 root 3, a root b. They're all surds. All a surd is a way to express an irrational number, which would be a long decimal. So if I just put in my calculator, root 18, you can see that it's just a long, horrible decimal. So we like to work with these irrational numbers as surds, as square roots, just to make things easier. So, the laws. The first law that you need to know, if you recall, you have indice laws. So that first question in the starter, we had a to the power n times by a to the power m, and the rule is you add the powers. So these are rules that you should know. Similarly with surds, we have rules for them as well. So it looks quite confusing, but if I've got the square root of a, that just means the square root of any whole number. So this is a generic law that can be applied to anything. So if I've got a surd times by another surd, the rule tells us that we can times them together inside the same square root. Okay, so we've got the square root of a times b. We can put them all inside one square root. An example for this would be if we had the square root of 3 times by the square root of 5, we could write that as the square root of 3 times 5, which could be the square root of 15. So we simply just times the surds together and put them in one square root. And we're going to use this law in a second and work backwards from it. The second law that we need to know is that the square root of a over the square root of b can be written exactly like example 1 as one big square root with a divided by b inside of it. Okay, so for example, we could just have the square root of 27 divided by the square root of 3, which could be written as a big square root of 27 divided by 3, which equals the square root of 9. And this is quite interesting because we know square roots have special relationships with square numbers. 9 is a square number. The square root of 9 is simply 3. So the answer to that question would just be 3. Using that law that we can divide them inside, 27 divided by 3 is 9. The square root of 9 is 3. Okay. The final law that we're just going to look at now is that the square root of a times by the square root of a, which essentially just means if you have the same surd times together, this happens. You just get a. You get the number that is inside the root. So for example, root 2 times by root 2 is just 2. Now the reason for this, if I go off on a bit of a tangent, you won't necessarily ever be asked to explain this, but the reason this is the case is because there is a law that tells us that the square root of a can be written as a to the power of half. So essentially what I have here is a to the power of half times a to the power of a half. A to the power of half times a to the power of half. And if I go and use the same law I used in the starter, which is if you have the same base times together, we can add the powers. What is a half plus a half? It's a whole. And a to the power 1 is just a. So what we end up with there is just a. So it's not magic. There is a reason behind why the square root disappears, and it is all to do with indice laws. But you just need to know that if you times the same square root together, you get what is inside the root. Okay, so hopefully you've managed to follow along there. If you are unsure, we're going to use these examples now to help us look at questions that you may be asked in exams. What's really important just to touch on is you need to know your square numbers. So on this second page here, it says that you should definitely know your square numbers. Okay, so if I just take these into a sheet over here, if we know our square numbers, why do we need to know our square numbers? Because of the relationship I just explained. All of these square numbers, if I square root them, they're not irrational decimals. They're not a horrible long decimal. They are actually whole numbers. If I square root 4, what do I get? 2. If I square root 9, what do I get? 3. If I square root 16, 4. If I square root 25, 5. It's really useful to know your square numbers to help you answer surd questions when asked to simplify them, which we are going to look at now. So if you don't know your square numbers, get into the habit of learning them. When you do surd questions in your exams, a really good tip is to write your square numbers out at the top of the page, because it's really useful to look at them to help you answer questions, which you'll see in later examples. So we will look at now, how can we use law 1 to help us simplify surds? Well, we have been given a surd, and we want to simplify this using law 1. And if you recall, law 1 said root a times root b equals the square root of a times b altogether. What we can do here is work backwards. We can break a single surd into 2 separate surds that times to make that number. So for example, if I am looking at simplifying root 12, the exam tip I would give you is, we know we're going to split it into 2 surds. So always write out 2 surds, 2 blank surds ready to be filled in. The trick to simplifying, and you really should add this note, is one of these surds should be a square number. And that is the key to these questions. And that is why it's so important that you should know your square numbers. So, if one of these should be a square number, now the job's a lot easier. I'm looking at 12 and I'm thinking, right, what square number do I know that goes into 12? Well, if I'm looking at the list here, clearly none of these will go into 12 because they're bigger than 12. However, 4 definitely goes into 12. So I can fill 4 in here, and you'll see why one needs to be a square number in a minute. If I fill in 4 times what makes 12? 3. So I can fill 3 in here. Why is this square number really important? Well, as discussed previously, we know that if you square root a square number, it becomes a whole integer, a whole number. So if I square root 4, the answer to this is going to be 2, because the square root of 4 is 2, times by root 3. Now mathematicians are very lazy. Remember, 2a means 2 times a. We're lazy, we don't write the times. Same thing applies here. We can make this look a lot nicer by just putting 2 square root 3. And that means exactly the same thing as 2 times square root 3. So the trick, write out 2 blank surds. Make sure one of them is a square number. And it should come out where you can square root the square number. Sometimes you can't simplify a surd, but if they are asking you to simplify a surd, they have definitely made it so one of them is a square number. So if we look at the next example, a little bit more confusing. This is the same style of question you'd see in an exam. Loads of students just leave it because it looks hard, but they're actually helping you here. So if we read it, it says, simplify 3 root 8 and give your answer in the form a root 2. So the key to this question here is, and this is where a is a positive integer, that just means a is a whole number. The key to this is they've actually helped you. So we could add this note. This tells you what your answer looks like. So they're actually helping you. They're telling you your answer needs to have the square root of 2 in it. So if we take this example now, we need to simplify root 8. We've got 3 root 8. We've just spoken about how do we simplify a surd. Well, let's just talk about what this means. This means 3 times root 8. Yeah. If they're touching, generally there's a time sign in between. And what we want to do... Yes, Josh, you actually... Well, learning up to the 15 squared is definitely useful. So you want to learn 12, 13, 14 and 15. So at this question here, 3 root 8 means 3 times root 8. We need to simplify this surd. We just discussed to simplify a surd, we write 2 blank surds. So we're going to turn root 8 into 2 blank surds, knowing that one of those surds must be a square number. However, they've helped us. They've told us my answer is going to have 2 in it, the root of 2. So I can fill in that one of these needs to be 2. Then I just think to myself, what do I times 2 by to get 8? 4. Surprise, surprise. Root 4 is a square number which is going to come out to be a positive integer. So I'm going to get 3 times, what is the square root of 4? Simply 2 times by root 2. Now that looks a little bit messy, but we can tidy this up. We've got 3 times 2 and then root 2. So the final answer to this question is going to be 3 times 2 is 6, root 2, and that is that question done. So, as you can see, does my answer look like what it should given the question? Yes. What is the value of a? A is this 6 here. A is 6. Okay. So, A little bit more of a wordy question, same principle applies. The trick to simplifying any surd is to try and break it into 2 blank surds and make sure one is a square number. Example 3. Looks a little bit more confusing, however, same rules can be applied. It's not asking us to simplify yet, it's just asking us to times those together. The way you deal with this, you have to remember that multiplication is commutative. What does this mean? 2 root 10, that means 2 times root 10 times 7 times root 5. If I expanded it out what that actually meant, it means this. You can multiply in any order. So remember, 2 times 3 is 6, but also 3 times 2 is 6. So it doesn't matter which way round I times them, I get the same answer. So we can use that to our advantage with this question. This 2 root 10 means 2 times root 10, times in the middle 7 times root 5. Here I can take my whole numbers and times those. Then I can take my surds and times those. So we're going to times the whole numbers together and the surds together. What does that give me? That is going to give me 2 times 7 is 14. Root 10 times root 5. Well, root 10 times root 5 is simply root 50. Because remember, root A times root B is equal to the square root of A times B. Now we can look at, can we simplify this? So we need to think, can we simplify root 50? Do we know any square number that goes into root 50 or 50? Yes, we do. So we can say this is 14 times exam skill, write out 2 blank surds. That is going to be 25. 25 is a square number and goes into 50. What do I times 25 by to get 50? 2. So here, now I can say, oh, that's good. Root 25, happy days. I know that that goes to 5 times root 2. So this root 25, getting it into a square number has made it very useful because I can actually work out as a whole that 25 square rooted is 5. Now it's a case of tidying this up. We've got 14 times 5, which is going to be 70, with a root 2 on the end. Generally, when you simplify surds, you'll always end up with a very small prime number, generally, or just a small integer as your final root, because it's hard to get a square number into 2. Not hard, you cannot. Okay, so something that's quite complicated, you should break down. And all I've done there is use very simple rules, but just broke them down in a logical order. So there are the types of examples that we're going to be looking at today. So hopefully you managed to follow along. If you're not quite sure yet, I'm still going to go through the questions in the worksheet. So the more you see this and the more you follow along, the easier it will become. So if we look at question 1. And if you're feeling confident, if you're thinking, yep, I can do this, crack on, you can get on with the worksheet. If you're still a bit unsure, you can follow along with me. But question 1 says, write root 48 in the form k root 3, where k is an integer. Now again, they're helping you. Looks horrible. This is helping you. Okay, that is help. It's what your answer should look like. So I need to simplify root 48. That's what that's telling me. This question is telling me to simplify. How do we simplify? You should be thinking every single time, I need to split this into 2 individual surds. And one of them has to be a square number. So an exam skill here, write your square numbers at the top. 2 times 2 is 4, 3 times 3 is 9, etc. Okay? So really good exam skill. Put your square numbers in up to 49. Don't need anything more than 49 for this question because 48 is the surd I'm looking at. Now the tip here is to find the biggest square number that goes into 48. If you go for the biggest one, there'll be less work in the long run. You can pick a smaller one. For example, 4 goes into 48, but so does 16. It's better to use 16 because there'll be less work for you. You might not know that 16 goes into 48, so you might have to think a little bit and just double check all of your square numbers, but 16 does go into 48, so I'm going to say 16, because remember, one of them has to be a square one. And I'm thinking to myself now, right, what do I times 16 by to get 48? Well, 3. I'm going to times it by 3. Okay, we're almost finished. They told me that 3 was going to be in my answer, which it is. So I could have just gone straight from here and put 3 in and then worked out what this 16 should have been. Why is this useful? Well, I know that the square root of 16 is a square number, is 4. Times by root 3, nice and lazy, just put 4 root 3. Okay. Exactly the same for the next one. I'm going to let you have a go at the next 2. I'll do them without talking so you can look up and check if you're unsure. But I'll give you a couple minutes to do 2, 3 and 4. Maybe 2 minutes. Okay, so hopefully for number 2, you realised to simplify. That's what this is asking you to do. They've told you what your answer needs to look like. You split 25 and you should spot instantly this is useful because 25 is a square number. Therefore, this will become the square root of 25 is 5 times root 2, which can be written in a lazy way as 5 root 2. Yeah, a mathematical way, you don't put the times symbol in between because it just looks easier and less confusing. 5 root 2 means 5 times root 2. And if you look at the question, it says k root 2, where k is an integer, whole number. Rk is 5. You can see here, this is k. Same thing for the next one. The only difference here is 5 root 27 is 5, and you break the root 27 into 2 surds. So they've told you again, they've helped you. One of your surds is 3, so you can just fill that in and then work backwards. What would I times by 3 to get 27? 9. Again, useful. 9 is a square number, so I end up with 5 times the square root of 9 is 3 times the square root of 3. Now you can just tidy this up. 5 times 3 is 15, and then you've got root 3. So my final answer is 15 root 3. Exactly the same for the last one. We're going to split this 20 into 2 blank surds. They've told me instantly that my answer is going to have a root 5 in it, so I'm just going to bang that in one of them. What do I times 5 by to get 20? Obviously 4. Very useful now. Root 4, that's a square number. That's going to be 2. So I end up with 7 times 2 times root 5, which all you have to do is tidy it up. 7 times 2 is 14. Times by root 5, no times sign, just put it next to each other. It's done. So hopefully you can see there, knowing your square numbers is useful. The question that looks quite challenging is actually helping you. And the key to all of this is breaking a surd into two individual surds where one is a square number. Every single time I've done one of these questions, I've wrote two blank surds ready to be filled in with either what they've told me in the question to help me or a square number. There will be questions in the description to practice this, more follow-up questions. We're now going to move on to expanding brackets with surds. Okay? So, expanding brackets with surds requires you to know two things. And I touched on this in the starter question. You must know how to multiply out two brackets. If you use the grid method, where you put it in a box and you write it here, I want you to try and get into the habit of just doing it with the FOIL method, where you just put lines, because it's quicker, it's easier once you understand it, and there's less room for error, I think. So if we expand this bracket, we're going to do x times x is x squared. X times 2 is 2x. 3 times x is 3x. And then 3 times 2 is 6. Whenever you expand out brackets, you will generally have things that need to be simplified. So here you can see 2x and 3x go together. We've got x squared plus 5x, since 2x add 3x is 5x, plus 6. That's my answer. So we're going to be using this method, but just instead of x's, we're going to have surds, square roots. Okay. The second thing that you should definitely be secure with, and I've put in a nice organised table over here, is what happens when you times positive and negative numbers together. So many students make mistakes on surd questions, not because they don't understand surds, but because they can't multiply positive and negative numbers together. So a recap, if you've got a mixture, the answers are minus. So if you've got a plus and a minus and a plus, that's a mixture of signs, it's a minus. If you just remember a mixture makes a minus, you're going to be okay. And if they're the same, you get a positive. So if you've got a negative times by a negative, you get a positive. And if you've got a positive times by a positive, you get a positive. If you can remember those two sentences, you're going to be okay. And these rules apply the same for divide. So let's take that and that parts of our understanding into example 1. We're also going to need to use law 1 to help us do this, or actually law 3 and law 1. But let's just go through. We're going to do this 2 times this 3, like we would with a standard double bracket. 2 times 3 is 6. Now we're going to do 2 times root 2. Well, we've seen this in the previous examples. 2 times root 2 can be just written as plus 2 root 2. Then we're going to do 3 times root 2, which again we've seen can be written as 3 root 2 without the times sign. And then we're going to do root 2 times root 2. Now we need to note back that root a times root a equals a. If you have the same surd times by itself, the square root disappears and you're left with just what's inside the surd. So if I'm doing root 2 times root 2, all I'm going to be left with is 2. So we can tidy this up, much like the example above, where the x's went together. You should be able to spot here that we have a root 2 occurring twice. Now you need to think of this as, just think of these as x's. What would 2x add 3x be? 5x. So what would 2 root 2 add another 3 root 2 be? 5 root 2. So this is going to become 6 plus 5 root 2 plus 2. Okay, so we've sorted out the surds. We ended up with this once we added them together. If this was a root 3, you cannot put them together. You cannot put these together. But because they're both root 2, you definitely can. A bit like you can't add an x and a y together. That is not 2xy. That doesn't work. But you can add like terms together. Okay? You should spot as well, this 6 and this 2, they're both whole numbers, they can go together. So my final answer, 6 add 2 is 8, plus 5 root 2. That is my answer. Could you write it the other way around? Yes, it makes no difference. If you had root 2 plus 8, that is also correct. So moving on to the next one. Very, very, very similar. We just have a negative, so we have to be careful. Remember, that negative is not floating. It is attached to this 3, or root 3. That is minus root 3, it is attached. So when we go through and expand out, we just have to be careful. We're going to do 5 times 2 is 10. And then 5 times minus root 3. Well, we have a positive and a negative, because that is a negative root 3. So a positive and a negative, a mixture makes a minus, and then 5 times root 3 would be 5 root 3. Now we're going to times root 3 and 2 together, which can be written as, they're both positive, so it's positive 2 root 3. And then we are going to multiply our surds together. Now, same thing applies here. We have got root 3 times root 3. But we've also, remember, these signs are attached, they're not floating. So we're doing a positive and a negative times together. So a mixture makes a minus. And then root 3 times root 3, well, that is the same as above. If you times the same surd together, the square root cancels and we just get 3. So we can tidy this up now. It looks a bit messy, looks really scary and horrible, but if they were x's, you would have no problem. What we've got is a 10 and a minus 3. They are like terms. They're both just positive whole numbers. Well, positive and negative. They're just an integer. And you should spot as well that we have got these two same surds. They're both root 3. And it's minus 5 and plus 2. So let's deal with the integers. 10 minus 3 is 7. And then we've got minus 5, well, minus 5 plus 2 would be minus 3. Or you could think of that as 2 minus 5 is minus 3. So we've got minus 3 root 3. And that's our answer there. Again, you could have that the other way around. You could have minus 3 root 3 plus 7. You would still get the right answer. It's exactly the same. Okay, moving on to the final example. Looks a lot more intimidating, but again, they're helping you. They're helping us here. This is what my answer needs to look like. So this is almost helping us. It's what my answer should look like. Answer should look like. And this bit here, it says expand 2 minus root 5 squared. Well, what does squared mean? Squared means times it by itself. So we need to times this bracket by itself. So what's that going to look like? That means I'm going to do 2 minus root 5 times by itself 2 minus root 5. Okay, same rules apply. Let's expand this out using the FOIL method. We're going to do 2 times 2 is 4. 2 times minus 5, it's not 5, it's minus root 5, would be minus 2 root 5, because 2 times root 5 is just 2 root 5. Mixture makes a minus. Now we're going to multiply minus, again, it's minus root 5 times by 2, which is going to give me another minus 2 root 5. And finally, the bit that most students get wrong, we've got a minus times a minus, so that makes a plus. And then root 5 times root 5, well, remember law 3, if you times the same root together, you get just what is in the root. So we're going to get just 5. The bit most students get wrong is the plus. They don't see that it's minus times minus. Same thing again, looks not very nice. However, we can tidy this up using simple like term simplifying. That's going to be the 4 and the plus 5. And then the minus 2 root 5 and the minus 2 root 5 will go to 4 and 5 is 9. And then minus 2 root 5, take away 2 root 5. And this is, again, where people get lost and confused. If I'm at minus 2 and I take away another 2, it's taking me down to minus 4. So that is going to be minus 4 root 5. Okay, so a variety of examples there. These are all the types of questions you'll see in an exam paper. Surds look really, really confusing and scary, but if you understand those 3 laws and basic negative and positive multiplying, basic expanding, they're not too bad. You just have to be really organised and careful. So, there are now a sheet of questions for you to practice, and then we'll look at an exam question, and that will be us done. There will be 2 more lessons on Surds, so there'll be a Surds 2 and a Surds 3, because it does get increasingly more complicated, but as long as you understand these foundations and really get to grips with using these rules, you're going to be okay. So, you can either crack on and do it yourself, or you can watch me do them. So, I'll just do the first one quietly, without talking, so people that are doing it by themselves can have an opportunity without hearing me do it. So the interesting part of question 1 is, hopefully if you expanded, you got 4 minus 2 root 3 plus 2 root 3 minus 3, which equals 1. Because the blue surds that I've highlighted actually cancel to 0, to nothing, because we've got minus 2 root 3 plus 2 root 3. And if you do minus 2 add 2, you get nothing. You get 0. So all we have to do is 4 take away 3, which is 1. So all of that horrible looking expanded double bracket actually just goes to 1. And if you don't believe me, go and put that in your calculator, scientific calculator, put it in exactly the way it looks, press equals, and you will get 1. So again, I'll just do the next one quietly to give you an opportunity. So quite a nice example, the next one. They're telling you what your answer should look like. They're also trying to confuse you by saying that you have to square it yourself. You have to realise that you need to do double brackets with the same inside. It's all positive, so it's nice and easy. You should have got 9 plus 3 root 5 plus 3 root 5 plus 5, because two of the same roots times together cancels the root out. Putting those together, 9 and 5 is 14, 3 and 3, so 3 root 5 plus 3 root 5 would just be 6 root 5. On the next one, exactly the same thing. So you can see that these questions, although they look difficult, they generally always look the same in the exams. Not very many words, just here's a surd, do this with it. So an interesting part here is if I do 1 times by minus, if I do 1 times root 5, you just get root 5, but a lot of students like to just put a 1 root 5 in front of it, because it helps them when they add it together, because we've got minus 2 plus 1, so that's going to give us minus 1 root 5 when they go together. Okay, so you could just write this as minus 3 minus root 5. Minus root 5 is the same as minus 1 root 5. Okay, and finally, it's nice and quickly. Hopefully some of you have got on and managed to complete those. You just have to be really careful with the negative numbers. If you're going fast, like I do sometimes, I go really fast and I miss negative numbers, or I forget a Surds law. Just take it slow and you'll be fine. We've got 3 times 3 is 9. 3 times minus 2 is minus 3 root 2. Minus root 2 times 3 is another minus 3 root 2. And then you've got minus root 2 times minus root 2, where the minus and the minus is a plus. And then we've got root 2 times root 2 is just 2. So when tidying this up, you just have to be really careful. This is where most mistakes are made. We've got minus 3 root 2 minus another 3 root 2, and we've got 9 and positive 2. So that is going to go to 9 and 2 is 11, minus 3 root 2 minus another 3 root 2 is minus 6 root 2. And generally students will make a mistake there. You're at minus 3 and you're taking away another 3. Where does that get you on the number line? Minus 6. Okay. So I will put links to questions that you can use to help follow this up in the description below, but we'll just finish now. And the key here is just being careful, knowing your negative and positive multiplication rules, and just really being careful when adding them together at the end. We'll finish on an exam question. So it looks very, very horrible. But if we take it line by line and read it carefully, it is very, very similar to what we've just done. So we have been told that A equals root 8 plus 2, and that B equals root 8 minus 2, and T equals A squared, which would be, if we just think about what we've been told, A squared, it would be this squared minus this squared, B. Okay? So that's what T is. It says work out the value of T. Give your answer in the form C root 2, where C is an integer. So they're really helping us here, because if our answer does not look like this with just one surd left over, we've done something wrong. So they're almost telling you, if your answer does not look like this, you have gone wrong. So you can always go back and check. And there is one crucial bit to this question where most students will go wrong. So let's just do what it says. T equals A squared. Well, what is A? A is 8 plus root 2. And if there's ever more than one thing and you're squaring it, it has to go in a bracket. So I have to put root 8 plus 2 squared. I've just done what it told me to do. I took A and I squared it. Right? I took A, wrong colour. I took A and I squared it. But because there's more than one thing in A, I've had to put it in a bracket. And then I'm going to take away B squared. Well, again, B has got more than one thing in it. So I'm going to put it in a bracket, so it's root 8 minus 2, and I'm going to square it. And just to coordinate that, that is B, the blue. So what we need to do is we need to square this, and then take them away. So let's just focus on A to begin with. If I take this off to the side, remember from the previous examples, if I square that, it's going to look like this. It's going to be 8 root 2 times by 8 root 2. And we can use our expanding rules to help us do that. So we've got root 8 times 2 is 2 root 8. We've got root 8 times root 8, which we know is just 8. We've got 2 times root 8, which is 2 root 8. And then 2 times 2, which is simply 4. Again, we should always tidy up. We have got, what do we have here? We've got a 2 root 8 and another 2 root 8. And we also have a plus 8 and a plus 4. So, what do we have? We have 8 and 4 is 12. Plus 2 root 8 plus 2 root 8 is plus 4 root 8. So my answer to squaring A is that bit there. So we'll just keep that in mind. And we're going to go off and do the same thing to B. So we're going to do root 8 minus 2 times by root 8 minus 2, because we're squaring it. And we are going to now multiply this out using the same method as we have. We've got root 8 times root 8, which is just simply 8. We've got root 8 times minus 2, so that's minus 2 root 8. Okay. And then we have minus 2 times root 8, which is another minus 2 root 8. And then we've got minus 2 times minus 2, which is plus 4. So again, we need to tidy this up. We've got an 8 and a 4. And then we have got, and this is where a lot of students go wrong, coming up. Then we've got this, minus 2 root 8 minus 2 root 8, which is, we've got 8 and 4 is 12. Then we've got minus 2 is minus 4 root 8. So, what do we need to do now? Well, my question is telling me, or this question, sorry, is telling us that we need to take this answer away from this answer. So you have to be so careful how we're going to write this. And this is where students go wrong. We need to say that this part was this. So our first part is, so we can say therefore, and that is just a fancy way in maths to write therefore. That's what that means. Therefore, we've got 12 plus 4 root 8. That's what I got, remember, when I expanded A, minus, because I've got to take them away because the question told me to, the answer to this one squared, which is this. Now, where students go wrong, you have to put it in a bracket because I'm minusing more than one thing. I need to do this minus this minus this. So let's have a look what happens. If you didn't put it in a bracket, most students will end up with 0 here because they'll be like, okay, 12 take away 12 is gone. And then they'll say 4 root 8 take away 4 root 8 is gone. So the answer is 0. But we have to be really careful. 12 minus 12 is 0. So the 12s cancel. And now we've got 4 root 8 minus, remember this minus is not floating. This minus is attached to this here. This minus is attached to this. So what's this telling us? 4 root 8 minus 4 root 8. Well, what happens when we do a minus and a minus? When we take a minus away from a negative number, we get a positive. So this is actually saying to us, add. Okay, that's telling us to add. So we end up with 4 root 8 plus 4 root 8, which is 8 root 8. Okay, so we're almost done. And as you can see, it's using every aspect that we've done today. This does not look like the answer they told me it was going to look like. They said my answer should have, it almost does, but the problem is, hopefully you can see, they said it should say root 2. My answer has a root 8, but we know we can simplify surds, and they're telling me that it has to be root 2. So remember, we can take this and we can say this equals 8 times 2 blank surds, where one of them they've told me has to be 2. They told me my answer has to have a 2 in it. What do you times 2 by to get 8? 4. What a surprise. 4 is a square number. 4 is a square number. What does 4 square rooted go to? 2 times the root 2. Okay, so now we can tidy up. 2 times 8 is 16. Root 2. My final answer is 16 root 2. And does that look like what they told us it should look like? Yes. C in my answer is 16. So that is going to conclude Surds 1. Hopefully you learned something. That is just the very basics of surds, being able to multiply using those laws and being able to simplify. As you can see there, we used all of the laws we looked at today in one question, taken straight from a GCSE paper. In the next few surds lessons, we'll be looking at adding and subtracting surds when they aren't the same. So in all of the examples we saw today, they were all the same surd, like a root 8 in this example, or a root 2, and we were putting them together. We'll look at what happens when they are not the same surd, and we will also look at something called rationalising the denominator. So thank you for tuning in. I hope you learned something, and I'll see you in the next one.